back, Professor Silva. Today, we're going to talk about the differences between three very important pieces of computer networking hardware. They're the switch, the hub, and the router. Now, a hub is actually considered a layer 1 device. If you remember from the OSI model, you'll recall that the first layer is actually the physical layer, meaning that there's no actual logical processing of data that's done on this layer. Layer 2 is what's called the data link layer, which is where frames are handled, and this is actually right where switches fit in. Layer 3 is the network layer, and that's where packets are routed across the public internet. So let's take a quick look at the three differences between these pieces of hardware. So a hub is a layer 1 device, meaning that when devices are plugged into a hub, it allows them to all communicate to each other. So you can think about a hub with maybe, say, 8 or 16 ports. If you have 4 or 5 different laptops and desktops all plugged in, they'll all be able to talk to each other, which is kind of nice. The problem is the hub doesn't do any type of logical comparison or logical analysis of the data. It's literally just an electrical connection from each port to every other port. So there's a couple of problems with this design. The first problem is performance. When you have multiple devices that are all talking at the exact same time, one device can step on the other, and this creates what's called a collision. A switch, on the other hand, is a more robust device. What a switch does is it actually handles communication coming in from one device on a port and actually connects it to a different port and sends traffic out to that particular port, whereas a hub will spread traffic across all ports at once. So this makes the switch a lot more efficient, especially under volume. And a router at the very top level will take packets and route them out across the public internet. So this is when traffic leaves from being a switch, or excuse me, from being on a switch and goes out across the public internet or to a different network. Now, I know a couple of guys might be saying, well, routers can be used inside of a network, and you're right. For the purposes of an introductory class, we'll talk about routers just taking traffic from your local area network and then moving it out to your remote network. So let's take a closer look at the way switches work. Again, hubs, pretty basic, just connect everything up, repeat the signal to all other ports. There are security concerns and performance concerns because data is transmitted across all ports, just an electrical connection. With the switch, switches work in kind of an interesting way. When you plug a device into a switch, it uses something called a MAC address to understand what device has just plugged into it. So in other words, every single device that you use on a network has something called a MAC address. And MAC is short for Media Access Control. And MAC addresses typically have two parts. The first part is what's called a vendor ID, and the second part is called the device ID. Put together, this is a hexadecimal value that uniquely identifies every network device in the world, right, one by one, that connects into a network. Now, the very interesting thing is that MAC addresses live on layer 2, which is actually the switch layer. So what happens is you plug a device into a switch, and the switch learns the MAC address of the device that just connected to it, because one of the first things that that device is going to do when it plugs into a switch is send out a frame with its source MAC address. That source MAC address helps the switch to understand what device is plugged in behind it. So if you have one device plugged into one port that sends its MAC address up, and you have another device that plugs into another port with its MAC address as well, what you end up getting is a switch that understands where one device is and where another device is, which is pretty cool. Because now the switch knows that behind, say, port number 2 is a device with MAC address whatever, and behind port number, say, 7, there's another device with a different MAC address. This allows the switch, when one device, let's say on that second port, wants to communicate with the other device, the switch knows exactly where these devices are, and it can actually create kind of a virtual connection between the two of these, which is pretty interesting. So the switch actually maintains all this information in something called a CAM table, which is short for content addressable memory. And the CAM table is pretty basic. It lives in RAM, and when a switch fires up and devices start talking to it, the switch will understand that on each individual port, a device is present based on the MAC address that it's provided. So the switch tracks all of this in the CAM table and basically uses it to switch data efficiently. It's pretty cool. Now, switches can operate in one of two ways. It can either operate in something called cut-through, or it can operate in something called store and forward. Now, in cut-through switching, the moment that a frame enters that switch, it starts to be transmitted to the other port on that switch. Right? So frame comes in, before the entire frame is received, it starts to get transmitted out to its destination, which is very efficient. Problem is, if any of those frames go bad, then the entire communication can get dropped. Or say, for example, that frame may not arrive, or it might arrive and it might arrive damaged. So there's a lot of different reasons why you want to check the data as it enters the switch before it's sent along its way. So the second method is something called store and forward, which is where a switch receives part of the frame, waits for the whole frame to arrive, analyzes it, and then sends it on its merry way. Once it arrives at the destination, then communication can return, right? And you've got two-way communication. Big difference being that when a switch operates in cut-through mode, the data is actually transmitted before it is fully received by the switch, meaning that some of that communication can get lost. All right, so that's pretty much it for how switches operate. There's one other detail that's worth mentioning. Switches can either be in something called, it can either be a managed switch or it can be an unmanaged switch. So a managed switch means that it's a switch that you can connect to and you can address it. You can do things like shut off ports, you can pull port statistics, you can get information about who the top talkers are, what types of protocols, traffic analysis. You can do all sorts of really cool stuff. And usually managed switches have a website that you can visit, which is usually the IP address of the switch itself, that will help you to manage it, get basic statistics about performance and things like that. So that's pretty cool. Unmanaged switches, on the other hand, are switches that you're probably most likely to see at your local hardware store, I mean, computer hardware store, of course. But basically, these are the devices that are going to be on the lower end, right? So whereas an unmanaged switch might cost you somewhere around $100, a managed switch could be 180 or $200, or even more, depending on what you need out of it. So managed switches are usually used in enterprise, and as an example, the most secure way that you could deploy a managed switch would be by default to set every port to be disabled, meaning that nothing works right out of the box. So if you wanted to enable a port, you may have to connect to that switch via either something like a console cable and then open up one port on the front of the switch for communication and open up other ports if you want to allow that. But by default, this could be off. There's lots of other ways you can talk about security on switches, things like switch port security and MAC address security. And anyway, security is a whole different field that we can talk about later. But basically, just understand that right now, if you want a managed switch, it gives you this type of capability. Unmanaged switch, probably the one that you're used to seeing. It's pretty much available right out of the box. So that's managed switch and unmanaged switch. One other kind of interesting thing is that you can also get something called PoE, which is power over Ethernet in your switches. PoE, I probably will save a separate video for PoE, but basically what PoE is it's the ability to power a network device over the same network cable that you're currently providing data service over, which is pretty cool. So for example, if you want to mount up a security camera, or if you want to mount up an access point, or you need anything at all that requires power, you can actually provide that power from the switch itself to actually remotely boot that device up and operate it. So it's pretty cool. We do a lot of PoE work with our business, but it's excellent. I mean, if you need to mount up an access point and it's really high up on the ceiling, you can get it to the point where basically you just take the cable, pull it up there, terminate it, plug in the access point, and that's it. You don't need to worry about pulling power up or anything else. So it's super handy. Same thing for security cameras, same type of thing for IP phones as well. So that's pretty neat. Moving on to routers, just to cover this briefly. So we talked about a hub, we talked about a switch. Now a router is a rather interesting piece of technology. So technically, a router is just a device that routes one network traffic to another. So you would have, say, 254 hosts on one network and 254 hosts on another. And if you want them both to talk to each other, you need some device that will allow this network to talk to this network. That's what a router does. Routing is a relatively complex topic when you get into the details. That's it on the surface. It's actually not more complicated than that in concept. You're basically routing networks and network traffic together. But we'll save routing for a different video because that's going to be a little more complicated. So just getting back to where you're probably most likely to see this, when you look at switch traffic, right? Switch traffic is all local. So you have an environment that has maybe, say, 100 or 200 people. At some point, the traffic is going to have to leave that local network. When the traffic leaves that local network, it has to be directed somewhere. And typically, this is what's called your default gateway. I'm not sure if you've seen the default gateway before, but basically it is your first hop out of your local network. A lot of times you might see this as 192.168.1.1 or something to that effect. So the way that this works is really, really simple. There's something called an address resolution protocol that's done, an ARP query, right? So when a switch is looking to get traffic somewhere and it targets it based on IP address, which again, an IP address is something that is assigned to every network device. It's not like a MAC address. It's a little bit different, so I should probably pause here and just give you some background on that. So when a device joins a network, it gets an IP address from something called a DHCP server. Basically, you plug it in, you get an IP address, and it allows you to communicate with other hosts on the network. It's similar to a MAC address in the fact that a MAC address is a device that is hard-coded onto that particular chipset for that network device. But IP addresses, you'll get them and you'll release them depending on the networks that you join. So you go to a coffee shop, DHCP will give you an IP address there, you'll release it when you're done. You join your home Wi-Fi, same thing, get an IP address, you release it when you're done. So what a switch does is a switch sets up communication from MAC address to MAC address, right? Which is pretty cool. But if you want to get traffic outside of the network, away from that local network, you need to have some way to identify what traffic is local to you and what traffic is not. So the way that a switch does this is the first thing that your client is going to do is it's going to ask for the MAC address of a known IP. So for example, if you're 192.168.1.1 and you want to get communication out to 192.168.1.5, you need to ask for the MAC address of 1.5. If you do not get a response to your ARP query, it goes to something called your default gateway. And again, in small networks, this is probably going to be your router, right? This is going to be like your little Linksys device or your Netgear or whatever little device is that's sitting on the very edge of your network. That's going to carry your traffic out to the public internet. So once your traffic reaches that default gateway, your default gateway is effectively going to use something called network address translation, or NAT, to associate your private address with your public address, and then it's going to have your traffic routed out across the public internet. So in this case, your router is actually routing. There is a set of technologies called NAT and PAT, network address translation and port address translation, which we can talk about later as we get up to the higher layers. But for right now, just understand that when traffic comes out of a local network, in order for it to leave out of a remote network, it needs to go through your router. So the routers, the way that you're usually going to see them, are going to be these small devices like a Netgear or a Linksys device that's going to take your traffic from a local network and route it out to a remote network. And again, it does that using a technology called NAT that we can get into a little bit later. So that's basically it. One other point of interest is that a lot of times those same devices that we're talking about that do routing also provide Wi-Fi service. They also do firewall type service. They'll do some basic intrusion prevention, detection. They'll do DHCP. So these devices do kind of a lot more than just routing. And we probably will take a look at one of those devices in a later video. But again, on a high level, that's basically the fundamental difference. So just to recap, you've got your hub, your switch, and your router. The hub is just a very basic device that connects all of your network components together on an electrical level. Your switch is a device that maintains what's called a CAM table, where MAC addresses are stored and where the switch knows from one device to communicate with the other. And you've got your router, where traffic is basically routed between multiple different networks. So hope this was helpful for you guys. We got more videos to come, and I hope you guys have a wonderful day.